Hello everyone. In Lesson 10 we look at straight lines a little bit more, the concepts of intercepts and slope, and then some special straight lines, horizontal and vertical lines. And we first define the intercepts, which are the points where the line crosses the axes. So we have an x-intercept, and just some things to note. If you're looking for the x-intercept, then y is going to be 0, and you're going to solve for x. And if you're looking for the y-intercept, then x is going to be 0, and you're going to solve for y. So one question will always be to identify the intercepts, and all you have to do is name the ordered pairs. So you can check this example to the pencil problem. It says to identify the intercepts, and so first off, the x-intercept will have the coordinates. You know that y is 0. It's always the opposite coordinate is 0, and it looks like in this case the x is -5. So as an ordered pair, make sure you put parentheses around the numbers separated by a comma, -5 and 0. And then for the y-intercept, we know that x is 0, and all you have to do is read the ordered pair, 0 and looks like 2 in the y. Okay, so that's the idea of intercepts. And if we want to graph by the intercept method, then we'll just simply find the intercepts by setting up a table. The easiest way is to set up a table, and in one instance let x be 0 and find y, and then the other instance let y be 0 and find x. And you can see that's what we did here. First we found the x-intercept by letting y equal 0, and that was 3. You could check through the work there. We'll go through a pencil problem in a minute. And then we found the x-intercept by letting, the y-intercept by letting x equal 0. That ended up to be -2, as you can see here. And then we just simply plotted those 2 points, and we graphed the line. We did find a third point as a double check, but that's really not necessary. You can opt not to do that, and so 2 points will be sufficient. So it'll tell you to find the intercepts and graph by finding them. So the easiest way again is set up a table, x and y, let x be 0, find y. So when x equals 0, then we have, okay, here's our go-to equation. You really don't even need to show the substitution, as I've mentioned before, when you're substituting 0, because that term basically disappears. Because if we're putting a 0 in, obviously anything times 0 is 0. So that goes away, and we just have -3y equals -24, and we can solve for y by dividing both sides by -3. So y is +8 in this case. So 0, 8 if you wanted to write the ordered pair. Okay, and then to find the x-intercept, we let y equal 0. So I'll say when y equals 0, then we have 6x minus 3 times 0 equals -24. And again, no need to show that, because it just drops out. So 6x equals -24, and dividing both sides by 6. Clean that up a little. Dividing both sides by 6 again, we get x equals -4. So -4 and 0 is the x-intercept. So then I'm just going to make a sketch here by drawing the axes, but hopefully you watched that video that I created on how to graph in my math lab. So we're just plotting the points 0, 8. So just pick a convenient scale, maybe call that 4 and this 8. 0, 8 would be right there. And then -4 and 0. So -4 I'll say is there, and here's my line. And typically, although in my math lab you're not able to do this, but typically we would write the equation of the line next to the line on the graph. Okay, so then we get, so that's graphing by the intercept method. Kind of a nice convenient way to go about graphing lines when both the x and the y's are in the equation. But then we get to special straight lines where not both x and y are in the equation. There's only one of them, either x or y is in the equation. And so there's either a horizontal line or a vertical line. And it's easy to realize what type of line we have, because just thinking intuitively, for example, if y is -3, just make sure you realize that there's no x, or if there's no y, that is, there's only either one x or one y, not both x's and y's, it's a special line. And to know which line it is, just think intuitively. If y is -3, then you can go down to where y is -3 and plot a point. And then if y is always -3, your only choice is to either move to the right or to the left. Because if you move up or down, that changes the y value. So if y is always -3, it's a horizontal line. And similarly, just intuitively thinking about this, to graph x equals 7, right away we know it's a special line, so it's either horizontal or vertical, because not both x and y are in there. If x and y are in there, both of them, then the line's going to have a slant to it, which we'll define momentarily. But if we only have a single x or a single y in the equation, it's a special line. And you just have to think intuitively, if x is 7, you can go to where, I'll just call this 7, that's going to be a point. And then if x is always 7, if I move right or left, that changes the x value. So the only thing I could do to generate another point is to move up or down. And that would be the line x equals 7. Many ways to think about this. I mean, you could say to yourself, okay, I'll build a table. Let me show this one quickly. X and y. Well, y is always -3. Pick any values you want. 0, 1, -1 for x. Y is always -3. And similarly here, x is always 7. So it doesn't matter if you pick -2, 0, and 2 for y. It doesn't matter what these values are. X is always 7. So there's a couple different ways to think about those special straight lines. The next thing is the slope of a line. So we use M for slope, coming from the French. Monter, Rene Descartes again, remember? But Monter means to go up or decline, and we could either have a positive slope if the line rises. So this is a positive, get used to M. This is a negative slope if the line falls as you move from left to right. And our first job is just to find the slope. And we'll get between 2 points. And we have an equation for the slope, so you're going to want to memorize this. y2 minus y1 over x2 minus x1. These are subscripts. When we say y2, it's y with the subscript of 2 minus y with the subscript of 1 over x subscript of 2 minus x subscript of 1. So that's our formula for the slope. Those subscripts are simply there to designate different values. And you can literally name the points x1, y1, and x2, y2, as we've done in this example. And it doesn't matter which one you pick, is x1, y1, or x1, 2, y2. Just be consistent. And then you just simply plug in the numbers into the formula and calculate your result. Okay, so here I'm going to rewrite these points, 7, negative 3, and the other point is negative 113. I'm literally going to label them x1, y1, and x2, y2. And I'll write the formula down formally. M is y2 minus y1 over x2 minus x1. And then just show the substitution into the formula. So I've labeled y2 as 13 minus y1 is a negative 3, so let me put parentheses around that, over x2. Make sure you're consistent and you go back to the appropriate x2 is negative 1, so don't mix them up, and then minus x1 is 7. So that gives, now just do the arithmetic. Double negative makes positive, 13 plus 3, 16, minus 1 minus 7 minus 8. Okay, that comes out pretty, negative 2. So that's our slope. And the larger the number, the steeper the line. The steeper it is as you rise, positive slope, or the steeper it is as you fall, have the negative slope. Okay, so then further, we have a special form for equations of straight lines. And that is what we call the slope-intercept form. So y equals mx plus b, where the number in front of x, when it is in this form, represents the slope, and the b represents the y-intercept. So you could read through the formalities in the example. The tough part is obtaining the form. Here's where students have a little bit of difficulty. So just to talk about example 5 quickly, we have to obtain the form y equals mx plus b. Isolate the y. And to do so, in this case, we first need to get rid of the 12x. So notice how we subtracted 12x from both sides. But we cannot combine the variable x and the number 6. So these are two separate terms. Then finally, to solve for y, we're going to divide by 3. So everything gets divided by 3. And now we obtain the form. And so if our form is negative 4x plus 2, then you can see that the slope is negative 4 and the y-intercept b is 2. So this asks us to find the slope, and we're given the line. This is what you might call standard form or general form. So we're going to isolate the y first by subtracting 2x from both sides of the equation. We have negative 5y equals, excuse me, again, these cannot be combined. Always convenient to write the x's first. So minus 2x minus 15. And now if we're solving for y, we're not cheating here, but we're skipping a step. You're allowed to divide everything by that number, -5. And so then we get y equals, okay, that's double negative, so positive, and I'll just write it as 2/5 x, and this becomes +3. So if this is now in mx plus b form, then you could see that the slope is 2/5. Okay, so that's one of the more challenging problems. A little awkward to get used to this step right here, I think, right? When you make sure you do not combine the x's and the numbers. Okay, then we get the slopes of horizontal and vertical lines. A horizontal line has a slope of 0, and a vertical line has a slope that is, we say, undefined. So you could realize this when you have a problem in one of two ways. Either when you plug in, if you're given 2 points and you plug in, you get division by 0, which is undefined. Notice the x-coordinates are the same. So that's telling you you have a vertical line. And then similarly here, well, if you go through the slope formula, it takes care of everything for you. But another way to notice, okay, so this I'm going to treat as x1, y1, x2, y2. And so we have y2 is 10 minus y1 is 10 over x2 13 minus x1 and minus 7. So that gives 0 over 20 or 0. But another way to notice that it is one of these special lines, horizontal or vertical, is that you have the same y coordinate. So if you have the same x coordinate, it's a vertical line, like the last example. Just think of plotting these. If you plotted these points, you're at -3 in the x, and you're at 5 and at 12, well, just that's a vertical line. Or if you plotted these points. We're at -7, 10, I'm just calling this 10, somewhere over here, 13, 10, somewhere over here. You can see it's a horizontal line. So there's many ways to analyze this. Okay, a couple more concepts. And we get to parallel and perpendicular lines. Parallel lines have the same slope. They look like this. And perpendicular lines have slopes that, well, excuse me, I'm so sorry. If you have a line, a perpendicular line cuts through it at a right angle. So there's a 90-degree angle. Call from the Pythagorean theorem. We use the little box to represent the 90-degree angle here. So that's perpendicular. And the easiest way to remember the relationship between perpendicular lines is that they are negative reciprocals. Meaning two things, basically. If you have the slope of a line, its perpendicular line is the opposite, that's the negative. So if it's negative, it becomes positive, and then it's reciprocal. So if you have a fraction, just simply flip it over. So we gave an example where we found the slope of the line between 2 points, and then we stated the parallel and perpendicular slopes. And that's what we're going to do in the pencil problem as well. So I'm going to recopy the points here. label them literally x1, y1, x2, y2. Find my slope by the formula. Again, y2 minus y1 over x2 minus x1. Make sure you show them as subscripts. A lot of people will write a y and then a normal size 2. It's a smaller 2 to the lower right subscript. Okay, plugging in to the formula, we have minus 5 minus 1 over minus 8 minus 6. So that gives negative 6 over negative 2, which would be positive 3. So the slope of a parallel line would also be positive 3. And then for the slope of a perpendicular line, if the slope is given to be 3, if you want to write it as a fraction, write it as 3 over 1. And then the easiest way to remember the relationship between perpendicular lines, so I'm going to say M perp, is negative reciprocal. So negative, so the opposite of positive is 3 over 1 is negative, but then the reciprocal, so flip over the fraction, negative 1/3. Okay, and then we get to the concept of slope in word problems as a rate of change. Here we mention the concept of traveling, say, distance over time, 50 miles per hour, that's our velocity. I gave an example. Of the weights of males, adult males in the United States. And we were given the 2 points, and we just found the slope, and that represented the rate of change. And we'll do the same thing here, population of buffalo. So we're given the 2 points. You might want to just rewrite them. This is 1960. In the year 1960, there were 527,000 people in Buffalo, and in the year 1990 that decreased to 368,000 people. So call this x1, y1, x2, y2, and we'll calculate our slope again. y2 minus y1 over x2 minus x1, so substitute 368 minus 527 over 1990 minus 1960. That gives us, go to the calculator, 368 minus 527 is negative 159 over 30. So our slope is, just divide that out literally, we get negative 5.3. Okay, so notice how it's negative, showing the decrease. And if we want to explain what this means as a rate of change, we could say that the population of Buffalo decreased by 5.3 thousand people per year Because that's what this represents. The number on the top represented the thousands of people, and the number on the bottom represents the number of years. So over, I should say, over the period from 1960 to 1990, because we don't know if that trend was beyond those years is the same. Okay, so that's the end of lesson 10. We have one more lesson left, and we'll look forward to going through the pencil problems to that one. Hopefully these are helpful for you.